And we even talked about like how exactly the things can be compressed in some form of optimization. Though we addressed a few tricks only, there are multiple such tricks available depending upon whether you are really interested into working in compilers. That time only you can work with other optimization techniques. So let us move further and let us try to address the same. Let us continue with the same aspect that we were talking about with respect to, say, formulating an object code from the assembly code. So let us try writing a code where we will be inputting, say, or we will be computing say factorial. Okay, so which is one of the favorite program generally we write. Okay, so let us say section dot data msg db, enter a number. Okay, so this is the first printf message that we are having. This is for scanf. Okay, and this one we are going to make use of for printing the result. Fine. So let us take section dot text. Okay. Section dot bss. So num resd 1 global main extern printf scanf main push num push fmt call scanf add esp comma 8 push msg call printf add esp comma 4. Now move xor ex comma ax, move ECX comma d word of number. We will take that number into ECX. Fine. EX. Move EX comma 1. Okay. Then mul ECX. Decrement ECX. Jump not 0 to test. Okay. Test 1. And test 1 is here. Fine. So JMP. Okay, we'll directly take push dword EAX, push MSG1. I think, yeah, MSG1. Call printf add esp comma 8. Let us try executing this, then I will explain this code. So if I give 5, then displaying me factorial. If I input say 6, if I input 2, if I input 1, If I input 3, now I have not considered here any condition right now. I'm just checking whether like ECX is reaching to 0. So one can check this. So gdb dot dot slash a dot out display EX display ECX. So we'll execute our code from here. Display $edx. Okay, breakpoint 18. Okay, now run. So we're inputting a number. Say we inputted 5. Now control, see the control, how exactly it gets passed. So I am displaying this program counter for your information. So currently my program counter is pointing here. Now here we are talking about one jump. Okay. Now when program starts executing, so let us say NI. So XOR EDX was made 0. ECX is having initial value as 0. EX is not having any value yet, but though it is having 1. So NI ECX is getting 5. That's what we gave as input here, correct? So ECX is getting 5. EX is 1, correct? Multiply EX comma ECX. Then decrement ECX. So you can see now if I see the flags, $E flags, there is only IF, correct? If I say NI again, so you can see that ECX was decremented as it was not 0. It is jumping, going back to test 1. Earlier it was on line number 24. Now it is at line number 22. Even you can see it was test 1 plus 2, test 1 plus 3. Now again test 1. So this address is going back to this, that decrement ECX thing, or that mul ECX wala. This statement, it is going here directly. Okay, so if you see, it is now in mul ECX. If I say NI decrement ECX jump not 0 test 1, you can see again it is EC mul ECX decrement jump not 0. ECX decremented again 1 jump not 0. ECX decrement ECX, now it is 0. Now you can see that when it is decremented, ECX became 0. Now when ECX becomes 0, this 0 flag is set, because we are checking what is the current status. It is not for ECX only. It is working for this flag. What is the status? Because this is arithmetic instruction. It is like ECX minus minus. Okay, so it is subtracting 1 from ECX. That's what this decrement does. So if you see here, this 0 flag was set, and that's how, like, it is not going to jump to now 22. It should have gone to 22. Now it will jump. It is not 0. It is 0. So that's why it will not execute this, and it will go to next statement, which is, you can see that it is completely changed. Earlier it was test 1. Now it is coming to test 1 plus 5, and then your code is getting executed. So our program got executed. Now the thing to see here is how the control is getting passed and how the addresses are calculated. Right. So you saw one example where it is checking or verifying this particular concept. Correct. So let me add something, some other code. So I showed you how exactly this jump is to be used. Earlier also we saw 1 or 2 examples. So JMP intro, conditional, unconditional. So already we saw conditional. I will not talk about this, but let me say section.text global main move EX, 10, move ECX, 20, jump to ABC. Add EX, 23, subtract ECX, 19. I'm just writing instructions. Here I'm writing jump PQR. So I'm using here simply two jumps. These jumps are, both of these jumps are unconditional jump. It is like using go to statement. If I assume most of you must have seen go to statement in C language. Correct. So that's what we are using. This is jump. The go to statement is handled by jump. So unconditional jump. So let us say my ABC is somewhere here. Decrement EX, decrement EBX, jump to. Okay. We'll write that jump PQR here. Fine. Now we have to write PQR as well. So let us say I'm writing PQR here. Okay, this program is not doing anything great. We only wish to see how the addresses are computed. And for jump instruction. So let us take this. So NASM -F ELF32 -L P dot LST. So we even can see this -L P dot LST first. Now see the computation. So test one is somewhere here like 2C. Correct. And we wrote that test one here. So it was FB. So we don't know, this jump may be for 75. In earlier session also we saw this. What is this 75 or what exactly is to be displayed with respect to each of the jump instruction. Now the thing to see over here is the addresses. Now how exactly you know where is FB? If 75 is said to be for JNZ, where is this FB? How to compute this FB? This is our undocumented problem for us right now. Correct. Secondly, let us try to address the current LST. So let me generate LST again. sp.lst. Now you do see here ABC, jump ABC. It shows 6. And here we wrote PQR. For PQR here it shows F9. Okay. Now let us try to compute the 06. How exactly it worked. So where is ABC? ABC is here. Correct. At this address. So let us compute. Let us compute in backward. How many bytes are? So 1, 2, 3, 4, 5, 6. That's why this 6 came. Now if I talk about this reverse jump. Okay. So this jump, when we are saying that we are jumping to a label, that label is not declared yet, then this is called as forward jump. Jump ABC and ABC is later, occurring later. This is forward jump. And this jump PQR, when PQR is known before reaching to this statement, then this is called as backward jump. Okay, this is forward jump, this is backward jump. Are you with me? Please raise your hand so that I can see that you are understanding whatever I'm trying to tell. So I hope you understood now what is backward jump and forward jump. Correct. Now our target is to compute these addresses, how to compute. So for forward thing, it is going to compute only number of bytes. So let us try adding some more statements there in the code. So I will say this is forward jump, unconditional forward jump. Let us say this. And here it is unconditional backward jump. Correct. I assume you are with me. Now let me add some more jump statements here. Jump ABC. Jump ABC. Now they are not going to do anything great, but let us see how the address computation is. Now this is nearer, correct? So 6. So compute this. 1, 2, 3, 4, 5, 6. Now with this, it became 8. Add these 2 there. So 6 plus 2, 8. 8 plus 2, 10. That's why A. 10 plus 2, 12. That's why C. 12 plus 2, 14. That's why E. Correct. So for every forward jump, like it is going to compute like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if you represent 14, okay, it would be 0E. That's why this 0E is there. Are you with me, everyone? So I hope you understood now forward jump computation. How to compute forward jump? From that location, try to compute how many bytes are there in the exact translation. So you compute only these bytes. So here we'll start computing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that is the reason why it is showing here E. So if I go here, it says C. C means 12. Compute it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Correct. Now from here, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct. Here 8. 1, 2, 3, 4, 5, 6, 7, 8. Correct. So this is forward jump. So is forward jump clear now? Yes. Any question with respect to forward jump right now? Now what happen? What will happen if I add one more jump ABC there? What would be first address here? Suppose if I add before this, I add EX, 23. One more JMP ABC. What would be the address for the first one? So this will be shifted, correct? Below. E plus 2. Should it be 1, 0? Because 0F would be there and then 1, 0. Let us try doing so. See here. So we got 1, 0. Correct? Because you are adding 2 more bytes. So if you keep adding 2 bytes here, so that address would be moving further. So how many bytes I have to pass? That's what this forward jump is telling. Now, how do we know that ABCs arrived first? So we are going to learn that through assembly process. What exactly assembler does? Probably from next week. Or probably on Saturday's, Friday's class. Okay, but what about backward jump then? How many bytes PQR is in the backward position? 1, 2, 3, 4, 5. What is this? How many bytes? 5 bytes. Correct? Now, let me take a editor. Let us write 5. 1, 2, 3, 4, 5, 6, 7, 8. We have to write that in 16. This is 8 bits, correct? So we want 5. So 5 would be what? This is 1. This is 1. Correct. So I'm going to take this. It is to be taken with 8 because it is in a byte. How many bytes we have to go back? Okay, so this is a byte. What is one's complement of this number? What would be one's complement of this number? 1, 1, 1, 1. Yeah, somebody unmuted. Award, Roshan. What would be one's complement for this number? Dia, are you there? Am I audible? Prerna?
Yes, sir.
Prerna, what is one's complement of this number? Are you there? Dia, Roshan? Really frustrating. Okay. I don't think you deserve position to be in MSc. Yeah, so one's complement is this. And now if I have to compute two's complement, what you do generally?
Add 1 in one's complement.
Add 1 in one's complement. So what it will be?
One zero one one.
1011.
One.
Is it?
Yes, sir.
So what would be this number? What would be this number? We wanted F9, correct? So as per code, what are the code? Sorry. What are the code that we saw? We wanted F9. So are we going to consider these two also? Okay, let us work out. Let us write F9 first. So what would be F9? If I have to write F9, how it will be 1111 and 1001. So how many bytes I should go back? So if I want that number, then probably let me take 0110. Okay, 1111 1001. Okay, am I right? What would be next? If you add 1 to this, it would not be F9. This actually is F9. This is one's complement that we are getting. Let me add one more reverse action. Reverse jump there. Okay, let me take PQR only so that. Now see what is the number shown. F9, F7, F5. The number is getting decreased, correct? For these three jumps. So how many bytes I should go back? So earlier I said like for this case, we were computing as 1, 2, 3, 4, 5. So was it 6 and 7? So if I take 7, say for example, correct 7, how you will write 7? Correct. How will you write 6? Correct. Now if I take one's complement of this is what? 7. Correct. This is what? 6. This two's complement, correct? Adding 1 into this. So This is 1's complement. Now this is 2's complement. Correct. Now if we see what is this number results to F9. Now if it is F9, where is F9 shown here? F9. So what was the original number for F9? 7. So how to compute? See, 1, 2, 3, 4, 5, 6, 7. That's why it showed F9. So now if I compute, there are 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I start with 9, what would be number? 0, 0, 0, 0, 1, 0, 0, 1. F 1, 0, sorry, 0, 1, 1, 0, 1, 1, 1, 1, then 0, 1, 1, 1. What this number would be? You can see this is F7, correct? Can you see that F7 now here? Correct. Now we'll for this let us compute for this jump. 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct. For this jump PQR, we got 9. That's why this is F9. Now F7. Correct. Now let us compute for this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct. Let us take 11. So this is F7. 11. How 11 would be? 0, 0, 0, 0. 8 plus 2 plus 1. Correct. 11. So 1, 1, 1, 1, 0, 1, 0, 0. Add 1 to this. 1, 1, 0, 1, 0, 1. If you see this number results to F5. Can you see that? Are you with me?
Yes, sir.
Correct. So that is how the addresses would be computed. So this is what we got F9, F7 and backward jump. Correct. Backward jump. This was number of bytes that we are required to go back. So number of bytes are 1, 2, 3, 4, 5. Correct. Sorry. From here we have to compute jump PQR. Even you have to compute 1, 2, 3, 4, 5, 6, 7. That's why we took here 7. Okay. So as per LST, this is line number 18, inclusive of line number 18 in this current picture. I'm considering this for jump PQR. I am counting this. Correct. For the jump PQR at line number 19, I am picking these many bytes. Correct. And for the jump, I am picking these many bytes. So for first jump PQR, number of bytes are 1, 2, 3, 4, 5, 6, 7. That's what we did here for 7. This was for now line number 19. 19. Correct. So line number 19. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what we computed F7. Now for this line number 20. Okay, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct. So this would be for 11 line 20. Fine. So I'm adding this LST for you peoples. There JMP LST. Let me save this too. Correct. Now let us try computing addresses for each of these cases. Okay, on our manual. So I'm sharing these 3 files for your reference. LST, ASM and TXT. Okay, I have added assembly code as well. and other things too for your code. And so is it reached? Yes. Yeah. So now let us try to take a sample case. We'll try computing addresses first. Okay. Emacs trial test.asm. So we'll add forward and backward jumps. So let us try computing the numbers. Correct. So we will include only jump things. So if I see here, what are the LST that we got? Correct. So I will take on simply these numbers. Only I will change this PQR address and ABC address. So we know that for this instruction, it is taking 3 bytes. For this instruction, it is taking 3 bytes. And I'm only changing position of PQR and ABC, and let us see what happens. Okay. Is that fine?
Yes.
So let me copy this code. Okay. Now let us try computing jump number for this case. Okay. How many bytes would be there? So let us pick this also above. So let me add here. This should be taking like if I see the less p.lst. Okay, let me see. Let me add this there. Okay. Now for this ex comma 10, number of bytes are 1, 2, 3, 4, 5. Correct. For move and for both the moves, it is 5 bytes. For add, it took 3 bytes. For sub also 3 bytes. Now let us try computing this addresses here. What would be address here for ABC? Let us try compute it. So each jump would be taking 2 bytes. Decrement would be taking 1 byte. Okay. So let us add those bytes here. 2 bytes. 2 bytes, 2 bytes, 2 bytes, 2 bytes. For decrement, both of them it took 1 byte only, correct? For your reference, 1 byte. One byte. This is again 2 bytes, 2 bytes, 2 bytes. Now let me know what would be number for this ABC now. Compute it. So 2, 2 plus 2, 4 plus 2, 6 plus 2, 8 plus 10. Correct. A, B, C, then plus 2 means E plus 2. 1 0 plus 2. 1 3. I took 1 1 or what? Sorry, I made a mistake. So let us compute the number of bytes here. So 2. So I'm computing for this, huh? So I'm computing from here. Okay, from here. So 2 plus 2 plus 2 plus 2 plus 2 plus 1 plus 1 plus 2 plus 2 plus 2. Is that fine? Now which one I'm considering? These three, then these two, like 1 1, and then 1 2 3 4 5. So 1 2 3 4 5 1 1. What would we count? 2 plus 2 plus 2. 1 2 3 4 5 6 7 8. 16 plus 2. 18. Correct? What would be this equivalent in hex? Now how many this will take? From here we have to compute. So 2 plus 2 plus 2 plus 2 plus 1 plus 1 plus 2 plus 2 plus 2. What this would be in decimal? Yes, please. बोलो जल्दी कितना आएगा सम? 16. Correct? Okay, good. Now for next again. Now यहाँ से 2 plus 2 plus 2 plus 1 plus 1 plus 1, sorry, plus 2 plus 2 plus 2. This would be 14, correct?
14.
This would be 2 plus 2 plus 1 plus 1 plus 2 plus 2 plus 2. This would be
12.
12. Good. Now this 2 plus 1 plus 1 plus 2 plus 2 plus 2.
10.
Good. This one 1 plus 1 plus 2 plus 2 plus 2 is 8. Correct. Now what would be x representation for this? So at least we can see here this would be what? 0e. Correct. This would be what? ABC 0c. This would be what? 0a. This would be what? 08. What is 16? 10. What is 18?
12.
1 2. Sorry. Okay. Now let us try computing this for PQR, unconditional backward jump. Number of bytes. So from here we have to compute. So 2 plus 1 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. बराबर है? Plus 3 plus 3 plus 5 plus 5. कितना आया ये? Compute the number of bytes.
31 sir.
बराबर है वो? मेरा काउंट देखो हाँ बराबर है क्या? You have to always see this. See, I started from here. इस लाइन से शुरू किया. 2 plus 1. I forgot 1 ना? Plus 1. 2 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 3 plus 3 plus 5 plus 5. ये कितना आएगा? बराबर अभी 1 2 3 4 5 6 बार 2 आया यहाँ पर. Yes. 3 2
32.
times 5. Okay, 32. How do you write 32 in hex? Correct? हेक्स कैसे लिखेंगे 32 को? हेक्स करो 32 का. या 32 ही काउंट आया ना नंबर ऑफ बाइट्स का. उसको कैसे किया था देखो, याद करो. हमने पहला जो फाइल लिखा था तो दिखाता हूं मैं आपको एक बार. इसमें देखो कंप्यूट कैसे किया था, कितने बाइट्स आप पीछे जा रहे हो। सो 32 है, 32 को आपने सीधा ऐसे लिखा है, करेक्ट। सो 32 आप कैसे लिखोगे अभी इस फाइल में, 32 मैंने जैसे लिखा था वैसे आएगा 0011 0010, ये बराबर है 32। अगर इसको मान के चले तो इसका बाइनरी वंस कॉम्प्लीमेंट क्या आया 1100 1101, इसका टूस कॉम्प्लीमेंट क्या आया 1100 1110, करेक्ट। सो व्हाट इज दिस नंबर, what is this number 8 plus 2 10, so a sorry 8 plus 4 c 12 आया ना वो, 8 plus 4 12 या c आएगा ना, ये बराबर है। और अगला क्या आएगा e, करेक्ट। अभी चलो इसका कंप्यूट करते हैं। 2 अभी इसका करंट लेके 2 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2 कितना आया 6 बार आया क्या 5 ही आया ना, प्लस 3 plus 3 plus 5 plus 5, ये 34 आएगा ना। देखो सम करो इसका,
यस सर
34। चलो 34 को लिखते हैं, क्या आएगा 0011 0100, इसका इक्वलेंट आएगा 1100 1011, इसका टूस कॉम्प्लीमेंट आएगा 1100 1100, बराबर है। देखो इसमें +1 किया तो 1 + 1 0 1 + 1 0, ये 0 + 1 1 आएगा, इसलिए ये क्या आया इक्विवेलेंट बोलो अभी इसका
CC।
ओके अभी चलो इसका कंप्यूट करते हैं, ट्राई करेंगे हम, देखते हैं कि हमारा बराबर आता है कि। चलो यहाँ से अभी इस 2 को इंक्लूड कर रहा हूँ, 2 + 2 + 1 + 1 + 2 + 2 + 2 + 2 + 2 + 2 1 2 3 4 5 6 यस, +3 +3 +5 +5, ये कितना आया 36, करेक्ट।
यस सर।
0011 6 करो 0110, इज दैट फाइन। अभी इसका वंस कॉम्प्लीमेंट 1100 1001, करेक्ट। अब इसमें ऐड करो एक 1100 1010, ये क्या आया
CA।
करेक्ट CA। चलो अभी इसको कंप्यूट करके देखते हैं, हमारे जो एड्रेसेस लिखे हैं वही वहां पर आते हैं क्या, कमेंट हमें दिखेगा LST में, देखते हैं हम। चलो asm-plf 32 trial test.asm-l trial test.lst, कहाँ पर गलती है तो देखते हैं हम। देखो अभी एड्रेस बराबर आ गए क्या, ये 12 आ गया, देखो ये 12 था ये 12 आया, ये 10 था ये 10 आया, ये 0 ही था ये 0 ही आया, करेक्ट। ये 0C था ये 0C आया, करेक्ट। ये 0A था ये 0A आ गया, ये 08 है ये 08 आ गया। और यहाँ पर देखते हैं अभी ये CE है, क्या गलती हुआ है हमारा, देखो कुछ तो भी गलती हुआ है। सो इट इज शोइंग अस E0, E0, करेक्ट। देखो क्या गलती है, काउंट करो नंबर ऑफ बाइट्स कितने आते हैं, यहाँ से कैलकुलेट करेंगे 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 22 + 10 कितना आया 32। देखो हमारा वंस कॉम्प्लीमेंट टूस कॉम्प्लीमेंट ठीक आया है क्या, कुछ गलत तो नहीं है उसमें। ये हमारा 32 लिखने में गलती हुआ है। 32 हमने डेसिमल वाला लिया था। पहले जो था हमारा नंबर ऑफ बाइट जो थे इट वाज डिफरेंट, करेक्ट? इट वाज इन लिमिट, क्योंकि वो 0a से पहले ही था। सो दैट मीन्स व्हाट, दिस 32 शुड बी कन्वर्टेड फर्स्ट टू कितना आएगा? 32 मतलब कितने बाइट्स आएगा? वो एक्स में कैसे रिप्रेजेंट करेंगे बताओ? हमें 32 एक्स में अगर लिखना, बाइनरी में लिखना है तो 32 कैसे लिखेंगे? जो तरीका हमने फॉलो किया, इट इज नॉट वर्किंग दैट वे, करेक्ट? When it is going beyond some amount of limits in the sense it is going beyond 10, because for 10 we could see in earlier case, like जो पहले वाला एग्जांपल था, जो आपको मैंने एक LST डाला है या जम ना लेस, इसमें थोड़ा सिंपल था क्योंकि क्या है, यहाँ पर जो नंबर ऑफ बाइट्स थे वो बहुत कम थे, लेस देन 10 थे। अगर आप देखो लेस देन 10, 1 2 ये 6 हो गए, 7 8 9 10 11 ही थे एट मैक्स। लेकिन ये जब जा रहा है बाहर तो जो 11 वाला था, हमने जो LST लिया था TXT, इस TXT में नंबर ऑफ बाइट जब हम वापस गए 11 को, हमने 11 को ऐसे लिखा बिकॉज 11 वी कुड मैप। नाउ द वे दैट वी रोट 30 और जो भी 30 31 जो भी था हमारा, वो हमने गलत तरीके से लिखा है। इट इज नॉट द वे दैट इट शुड हैव बीन रिटन, करेक्ट? So we have to definitely make the change in our understanding. So what was that change? Let us see. So ये जो number of bytes हम लेके जा रहे हैं, correct? 32, ये हमारा number of byte computation ठीक है, लेकिन यहाँ से गलत है। इसका जो conversion है वो गलत है। अभी 32 लिखेंगे कैसे बोलो बाइनरी में? सो पहले ये लिख लेते हैं, 32 होगा मतलब कितना आएगा?
Sir, 6 times 1.
2⁵, 32 आएगा ना? ऐसे आएगा ना ये?
Yes.
है कि नहीं? ऐसे आना चाहिए ना? ये 32 है, इसको अभी कन्वर्ट करो वंस कॉम्प्लीमेंट में, 1 1 1 1 0, सॉरी 1 1 1 0 1 1 1 1। अभी इसका 2's कॉम्प्लीमेंट निकालो, कितना आएगा? बराबर है? ये नंबर क्या आएगा? वन जीरो। कितना आएगा? आप लोग हो मेरे साथ?
यस सर।
कितना आएगा बोलो? वहां पर हमें क्या दिखा था LST में? हमें क्या चाहिए था? E0, E0। यहां पर E आना चाहिए, क्या करना पड़ेगा E अगर लाना है तो?
सर
सॉरी
सर तो बायनरी मध्ये चुकलाय 32
माझा ना लिहिताना। ओके, कुठला इथला?
हा सर एक अजून
किती लिहितो सांगा. 2:0 1 2 3 4 5 इथं पाहिजे ना 1. बरोबर.
हो सर.
हाँ ठीक है चलो अब नेक्स्ट बोलो. अब इसका क्या आएगा. 1's कॉम्प्लीमेंट 1 1 0 1 0 0 0 नहीं सॉरी गलत किया. 1 1 0 1 1 1 1 1 करेक्ट. इसका क्या आएगा. 1 1 0 यहाँ पे 1 0 करके आएगा करेक्ट. एंड देन 0 0 0 0 इफ यू ऐड 1 इनटू दैट. सिमिलरली अभी 34 कैसे लिखेंगे. 0 0 1 0 ये 32 आया. 0 0 1 0 करेक्ट. इसको लिखते हैं. इसका क्या आएगा. 1 1 0 1 1 1 0 1. इसका आएगा 1 1 1 1 करेक्ट. नहीं 1 1 0 1 1 1 1 0 बराबर है. देख लो एक बार. बोलो इसको चेंजेस बोलो.
सर त्याची कोडमध्ये व्हॅल्यू बघा ना.
एक मिनिट थांबा. लेट मी वर्कआउट. Let me work out this. I'm computing. Till that time, you try to compute it and see what is the number shown. Let us not see that number. Try to address it here only. Yeah. So let us try first computing this. ये कितना आएगा बोलो. ये नंबर कितना आया अपना. ये E0 आया. ये कितना आएगा. Let us try seeing it here first, then we will address. ये कितना आएगा. 8 + 4 12 12 + 1 13. हमारा गलती होगा तो पकड़ा जाएगा. देख लेंगे हम क्या करना है उसको. तो देखो 34 बराबर है मेरा लिखा हुआ कि गलत है. 34 शायद 32 + 2 बराबर है ना. 32 + 2 34 हो गया है बराबर. तो इसका 1's कॉम्प्लीमेंट निकाला 1 1 0 1 1 1 0 1 करेक्ट. उसका 2's कॉम्प्लीमेंट निकाला तो क्या आएगा. ये नंबर क्या आएगा बोलो. देखते हैं हम कंप्यूट तो करेंगे कितना आता है देखते हैं. बोलो ये नंबर क्या आएगा. Can you hear me?
D.
Huh? DE. DE सांगितलं ना तू?
Oh.
Okay. Let us see like whether it goes that way. ये 36 को लिखते हैं. चलो कितना आएगा? बराबर है 32 प्लस 4. ठीक है ना? ये कितना आएगा? 1101 सॉरी 1011. इसका आएगा 1101. नहीं, रिवर्स कंप्यूट करके आएंगे. 0 0 1. हाँ, अभी ये 1 वैसे रहेगा. देखो ये कितना आया तो D C. Yes.
Yes, sir.
Okay. Let us try seeing that. देखो DE and DC दिख रहा है? Okay, so let us generate this file one more time. देखो अभी ठीक है क्या? ये E0 हमने E0 निकाला. ये E0 यहाँ पर था. DE हमने निकाला DE. यहाँ पर है DC हमने निकाला DC. So are you with me now? I hope you understood now how to compute. Yes.
Yes,
Backward or forward. ये एग्जाम्पल शायद आपको मदद कर दे. करेक्ट. सो लेट मी मेक स्मॉल चेंज इन दिस कोड. CP जितने सारे अनकंडीशनल JMP लिखे थे हमने, वी रोट ऑल ऑफ देम एज JMP. इंस्टेड ऑफ इट आई विल राइट JZ और सम इंस्ट्रक्शन. Now do we see any change there? That's what we want to check. सिर्फ वो ऑपकोड चेंज होना चाहिए. Correct. So I replaced all of JMP to JZ. Okay. Simply let us see. Sorry. Now see, there is no change. Only opcode will be changed. 1 2 1 0 0 E 0 C 0 A 0 8. Correct. यहाँ पे भी देखो E0 DE DC. So your jump is not making the change in the what you can call it as address computation. So no matter which jump instruction is there, this address computation should be done this way only. समझ में आ गया? Everyone? You can raise your hands if you don't want to speak so that I can see like you understood whatever I tried telling you, how to compute the addresses. Good. Only 2 people. 3 6. Good. Very good. So I'm sharing both of these files for your reference. Okay. Trial test ASM, trial test LST, trial test ASM. I'm giving you LST along with that code so that you can use it and see exactly what is happening there. Correct. Then because it will help you rather to understand how exactly we completed the calculation. of those all addresses. Fine. So check whether you see these files. Yeah, so these are the files. Try these ones. Okay, so we have finished almost like most of the things which are necessary to be addressed by us. So from next session, we'll try to understand how to design our own assembly if at all we have to implement it. And as I stated, we'll be having a test related to this computation. Okay, in a safe browser. Note that we are going to conduct this exam in safe browser. So probably next week we will try to have it so that you can finish your safe browser installation on laptop. Fine. So I don't want you to make use of NASM. Fine. You are going to share your screen through the browser. Try to find out how exactly the safe browser is to be installed. Fine. So I'm sending you the links for that SCB. You can take help from your seniors. Also, I'm sharing videos. So you can use Windows as well, because I don't want you to make use of desktops. Like those not having laptops or PCs, then I assume like okay, we'll work out, but at least try to, because for the examination we'll be requiring that later as well. Right now we'll see what is to be done, but I am forwarding few messages, okay, which I shared right now. So if you don't have laptops or desktop, then it would be a problem for you, because this course would definitely require you to have laptops or desktops so as to be helpful for you. Okay. So try to see. I have added this for Windows, Linux. Okay, but you can search about SAFE exam browser for Windows. I'm adding 2 videos too for this purpose. Okay, try to see them, try to use, like try to install it. When it's done, we'll work out and see what can be done. Fine.
Sir, what will be the pattern for the test?
I will let you know when I declare.